So today we are going to talk about light and color. We're going to talk about primary colors and mixing colors. We're going to finish off today probably with the Samolyov effect, which is Russian, and I don't know if I'm saying it right, so if I'm butchering it and you speak Russian, then I apologize, and then come teach me how to say it, because I don't know how to speak Russian. We may get to some questions. I made the executive decision with the help of my fourth period class to move the quiz back until Monday. If that does not work for you for whatever reason, please come talk to me. I didn't feel like we were going to have enough time to get all of color done and do some review time. And I didn't want to throw you into this quiz with no review time. The content is not really hard because it's conceptual, but there's kind of a lot of it. And so I wanted to make sure that we had some time to review. So tomorrow we're going to review, and then we may also do a short lab experiment that is for the next set of things that will not distract from what you understand. It will just be like the next thing that's on our list. Does that sound okay? Again, if you know you're going to be gone on Monday, or if there's a reason that Monday is just like you're taking 17 other tests on Monday, then come talk to me and we'll work it out, okay? But otherwise, let's plan on Monday for your quiz over this stuff, because I just don't want to rush it. It's not worth it. All right. Any other logistical questions for me? If you are intending, I had one other thing in my head. If you are intending to take a retake on the last quiz that we did, and you have not yet talked to me about that, make sure you touch base with me today, okay? I'd like you to get that done today or tomorrow, unless there's an extenuating circumstance. So, cool? All right. Go ahead and pull your paper out. Pull out some notes. We're going to jump in and take some notes on color, do some experiments with color, learn some color stuff. I'm going to start out by giving you 2 minutes at your table to write down what you know about color. Okay? Whatever it is. 2 minutes, talk to your table mates. Write down what you know about color. Go. You got some stuff written down, right? Let's talk about it. What's something you've got? Get us started. What's that?
3 primary colors.
3 primary colors with an exclamation mark, because you seemed really excited about it. Yeah. Do you want to expand on that, or you just wanted to put that out there?
I know that red and blue are blue and yellow. Is that one of them?
Red, blue, yellow. Huh? Yeah. So say that again. So different colors have different frequencies? Yes, they do. What else you got? Go ahead, Ethan.
The color that you see is the frequency that bounces off an object.
The color that you see is, say that again.
Is the frequency of the light that bounces off.
Frequency that bounces off of the object. That's awesome. Cool. Well, and we're going to add more to that in just a minute, but go ahead. Yeah, and then we'll come over here.
Oh, I'm not sure, but doesn't every color absorb all other colors except for that color that it is?
Mm-hmm. And that goes exactly with what he was saying. So, okay, so say that one more time, if you can remember what you said.
Like every color absorbs all the other colors except for the color that it is.
I'm going to say every colored object. Is that okay? Absorbs all the other colors except the color that it is. Is that what you said? Cool. Yes. And if that makes sense to you, fantastic. If this is the first time that you've been hit with that idea, then I don't want you to get upset. We're going to talk about that today. And it will make sense by the end of the day today, I promise. Okay? Madeline, you had your hand up a minute ago.
You like can't make primary colors and mix things together.
Okay. So the idea of a primary color is that you can't make it. Is that right? Okay, so you can't mix or make primary colors. Okay? Yeah, go ahead.
So I feel like TVs and printers, they use like the change of blue and yellow, but does that mean that they're actually making those frequencies? Like, or is it like just
They're not tricking your eyes. I'm just gonna make this little list that says TVs, printers, and crayons. They all use color in different ways. And so I want you to be aware of that. We're going to talk about what that means. Is that okay? Can I leave it right there? Because you're talking about like what's tricky, and it kind of is tricky. It's kind of weird. We're gonna kind of start mixing in there and see how we do. Okay? They all are different. What else? Yeah. Yeah, there totally are. So you've got the primary colors, then I'm going to also say in here secondary colors. Does anybody know how to spell tertiary? I don't spell well. We're just going to say it out loud. Tertiary. It's the third layer. The ones that I'm going to pay attention to and really worry about are the primary and the secondary colors. And I'm also going to put in there another phrase that we want to talk about, and that's complementary colors. And that's related to the primary and secondary. We'll get there too in just a second. This is a really good list, you guys. What else do we want to add to it? Kayla, did your table have other things that you guys were talking about? Roy G. Biv! I told you the story about Isaac Newton, right? Did I tell you this whole thing? Okay. About how he screwed it all up? Yeah? Okay. Yeah. Because he screws everything up. Yeah. So I've been starting to write it like this. Yeah. With the I in parentheses, because that's a tertiary color. That indigo. It's not a primary, secondary color. Alex, did you guys have anything else back there? It's all light. Yeah. It all comes from light. Yeah, go for it. That's awesome. And that's a very nice, like, kind of piggybacking on that, because there's light in all parts of the spectrum, right? We don't really talk about colors when we're talking about like the radio waves or the gamma waves. We talk about the light, and that's when we're kind of being very, human centric. We're saying, really, we're just talking about the visible part of the spectrum. Except I can't spell again. Spectrum. There we go. The visible part of the spectrum, just a little friendly reminder in case you didn't have it written down or we forgot it from before, is really only about 400 to 700 nanometers. This is the wavelength we're talking about. Okay? It's just a little tiny slice of that EM spectrum. Not very much. To make sure that our brains are working and we understand this, talk to your table mates real quick. 400 nanometer light, is that the red or the violet? 700 nanometer light, is that the red or the violet? Talk to your table mates right now. See if you can figure that out. If you need to look at your notes, by all means do it. And remember, this is measuring wavelength, right? Are you ready to vote? Okay. So 400 nanometers. Is that the red light or the blue light? Raise your hand if you think it's the red light. Raise your hand if it's the blue light. See some hands that didn't go up at all. Let's figure it out. Is this the bigger wavelength or the smaller wavelength? That's small wavelength, right? Let's look at it. The electromagnetic spectrum, the small wavelength, these are little wavelengths, right? What part of the spectrum are we talking about? Violet? Does that make sense? Small wavelength, yeah.
Okay, I'm confused on what like the 400 means. Like, is that like the distance for being one cycle, or?
So it means like from here to here, that would be like a wavelength, right? Crest to crest. Does that make sense? Yeah. No, and that the reason I did this is because I will be completely honest. I've been teaching this for over 10 years. I've been doing this stuff for a really long time. And every single time I think about it, I have to think, okay, am I talking frequency? Am I talking wavelength? Because both of those numbers are really, really big/small. You with me there? I get it mixed up, I'm going to say 30% of the time. And again, I've been doing it for a long, long time. So you have to think it through and say, okay, small wavelength, I think about that as being really, really high frequency, high energy, close to the UV, to the ultraviolet, the dangerous one. You with me there? Okay. High energy, high frequency, low wavelength. That's how I get to my purple. I'm going through that with you because, like I said, I have to do it every time because I get it a little bit confused every single time. 400 is the small wavelength. This is going to be your violet, your purple, the blue side of the spectrum. I don't know why, like when they're talking about Doppler shift, they just call them red and blue shift. I don't know why there's not a lot of love for purple in that, or violet in that, except that when we start talking about primary colors, violet is not one of them. If the violet or the blue end of the spectrum is down at the 400, then 700, those are bigger wavelengths, lower frequency, lower energy. That's going to be what part of the spectrum of the colors? It's going to be red. How are we doing? We okay? Sweet. Okay. Anything else from your big long list of awesomeness that you want to add to this list of awesomeness? I'm going to start way up here at the top. We're not going to just go straight down through, but it's a great place to start. When you were in preschool and in kindergarten, you started taking art classes, your art teacher teaches you this, right? Red, blue, and yellow. And the nice thing about red, blue, and yellow is that if you got a red crayon, a blue crayon, and a yellow crayon, you can make anything you want, right? Because if I take my red crayon and I color a little bit, then I take my blue crayon and I color over it, what color am I going to get? I'm going to get purple, right? So maybe I don't have a purple crayon, but really I've got everything I need to make purple. I've got a blue crayon and a yellow crayon. What color can I make? I can make green. And this is all real and true. Somebody last period was like, does this really work? I'm like, heck yeah, it does. Oh yeah. And then, if I've got my red and my yellow, I've got those two colors, I can color them together. And what do I get? Orange. And the fun thing is that not only can you get just these 6 colors, but if you do a little bit more red and a little bit less blue, then you're going to get something that's a little bit, to the red side of purple. And that's how you get the whole rainbow and all of the colors in the crayon box. Life is good? Okay. We all know that. We've known that for a lot of years. If you're 18, you've known that for at least like 15 of your years in life, right? Okay. I'm going to ask you right now, though, to throw that out the window. What? Or pack that in the little happy crayon part of your brain. Okay. Because right now, we are going to step into the world of light and color. And in light and color, these are not our primary colors. Again, I'm not telling you that your art teacher lied to you or that this does not work, because it absolutely does. And thank goodness, because I've just got a big box of crayons at home and sometimes I can't find the purple. And otherwise, my 3-year-old is just going to start bawling if we can't make purple, right? But I got my red and I've got my blue and everything will be okay, right? It's all good. But when light starts coming in, it's a little bit different. So we're going to talk about the primary colors of light. Ready? Here we go. You spend a whole lot of your life staring at screens. Yeah, whether you like it or not. And all of the screens that you stare at are projecting light at your eyes. And it's not just black and white, right? Black and white would just be on and off. But all of the screens that you stare at have all these pretty colors on them. And all of these pretty colors come from 3 colors. Really in the projector, really in your phone, really on your Chromebook, really anywhere that you look, there are just 3 little lights that go on it and different brightnesses, different concentrations, I guess is a better way to say that. And we get all of the colors that we want. What are those 3 colors? Do you know? No, not magenta. Think simple. Blue. Yeah. Want to come up with another one?
Green.
Green. Yeah. Green? Is that what your kindergarten teacher told you? Your kindergarten teacher did not tell you to get that green was a primary color, right? Your kindergarten teacher or whoever, I don't know who it was that told you this, told you that you had to use blue and yellow to get green. But I'm telling you that green is a primary color. Yeah, I like to cause trouble, I suppose. What's the third one? Anybody know? Good guess. Not quite, though. It's red. It's red. All right. So we're going to do a little demo because it's more fun than me just telling you things and you don't. This is one of those things that you can't really just believe by somebody telling you. You got to see it. So I'm going to pause my little. I'm going to unmute my pretty screen here, maybe. There we go. And we're going to draw what we've just seen. Maybe if my thing will go. I don't know why it's not going. Hold on. Please hold. All this silly stuff. Okay. Fantastic. So now we're good. We're all together. Okay. So on your paper, you're going to draw this. Now, if you are a color person, if you like this sort of color thing, and you feel like you need to make your picture color coded and you would like to borrow some of my colored pencils, you are very, very welcome to do that. I'm just going to leave them right there and you can get up and move as you need to. What we're going to do right now is draw. Oh, not that. You don't need to draw that. You need to draw. What are our primary colors again? Red. So let's start with red. We'll put our red. I'm just going to draw a little circle. We're doing like a big Venn diagram. This is like the best use of a Venn diagram ever because it's literally just shining lights, right? So we got red. Pick another one. What are we going to choose next, Thomas? Blue. And again, don't just let those people that are sitting over there. If you want to go get colors because it makes you happy and it makes it like it'll work better in your brain, absolutely hop up and grab them if you need them. And then my last one is going to be green. And we're going to remember here then that this one and this one and this one, these are the primary colors of light. Okay, red, blue, and green. Again, it's weird because it's different from what you've been taught since you were 3 years old, and I'm telling you new things. But again, I'm showing you this too, right? So hopefully it's reasonable to be convinced of this. Now, let's record what we know. What was the first one? So Cassidy, what color did you have? Blue. And then who got up next? Alex, you got up next. And you had what color? Green. And we combined the blue and the green. So that would be this little space here. And what color did we get, friends? We got cyan. So cyan is kind of like a turquoisey color. Looks something like this. It's spelled C-Y-A-N. It's one of those colors that you've seen but maybe not named that way before. I don't think that there's a color in the crayon box that says cyan. So then Josie got up and she said, okay, well, I'm going to do red because that was the only thing that was left. And she also likes red. Do you like red also? Oh, reds. I feel like red is one of those colors that like doesn't get quite enough love. Not gonna lie. We did red and green. We put the red and the green together. And what did we get? This is the weird one. It's weird. It's yellow. Red and green crayon don't go. They make brown, and brown is beautiful. But that's crayon. That is not light. When I put red light and green light together, I get yellow light. It seems kind of surprising because it feels like you're getting something lighter. Okay. And then finally we had Alex turn his green light off, so we had just the red and the blue together. Combine those two and we got magenta. Yellow, cyan, and magenta are the secondary colors of light. Right in the middle. If I turn my red light and my blue light and my green light on, what do I get? Plain old white light. The stuff that we know and love. White light is the combination of all light. White light is the combination of all light. If you have any like cut glass in your house, like on a window, we have a really, for whatever reason, we didn't pick it, but a really ornate front door with a window that's got like cut glass on it. And every evening when we're getting ready for dinner, there are rainbows all over our living room. Because the white light from the sun comes in and is split up into all of the colors, okay? Because that white light is really just a combination of all the colors in the rainbow. Okay? How are we doing so far? Okay? Okay. So then there was one other term that I wanted to share with you, and then we'll come in, we'll do some more up here. And the other term, we had primary, we had secondary, and then what was that third one that we had up there? We had tertiary too. Yeah, we're not, but I was thinking more this complementary idea, right? Complementary is kind of like opposites. So the complementary colors are red and cyan. Okay? Complementary color of blue is what? What's across from blue? Yellow. So yellow light and blue light have nothing in common because yellow is made from red and green, blue is blue. So if I take a yellow light and a blue light, what would I get? If I take a yellow light and a blue light, what am I going to get? I'm going to get white. If I take a red light and a cyan light, what am I going to get? White. Right? And then the last one would be green and magenta. Green and magenta are also complementary colors. Complementary colors. So complementary colors are colors that do not have anything in common. Red and cyan, blue and yellow, green and magenta. You doing okay? Okay. I want to do one more demo up here with these lights. I need different people to come on up. So we're going to pick different groups. Let's see. Cara, do you want to come up? Would you be willing to? And maybe let's do Clay and Grace. Does that sound okay? So I'm going to turn this off once you guys are all good. come on up. Whoever gets up here first gets to pick your color, and you're going to come sit on the floor for just a second with that as well. I'm going to turn off my recording. Holy cow, we're almost done with our time? How did that happen? Holy bananas. Okay, well, we're just going to keep going. Let's see what we can cross off our list. Good thing we're not taking a quiz tomorrow. Okay. We wouldn't have been ready anyway. Okay, we got the 3 primary colors. We got the complementary colors and the secondary colors. Different frequencies. Oh, we got to talk about this color that you see business. Now, before we do that, though, I'm actually going to come down to this thing right here. I tried to look for, and I did not find in my back room something to show you this, but I'm just going to tell you this right now. So we talked about how crayons are different, right? That our preschool teachers and all of them, they weren't lying, they just weren't teaching about color, okay? Red, green, yellow, or red, blue, yellow. TVs, any sort of monitor, any sort of light-producing medium is always going to be what 3 colors? Yep. Printers are a little different. Printers are talking about pigment. Okay? Pigment is opposite of light. Does anybody have a color printer at your house? Yeah? Have you ever looked inside it and looked at the cartridges of the color printer? Are they red, green, and blue? They are cyan, yellow, and magenta. And often there's a black one too, because otherwise they don't have to waste all that. Cyan, yellow, and magenta are the primary colors of pigment. So anytime that you get anything that's printed, if it's printed in color, I don't have anything printed, but in a book like this, all of the stuff that is printed, they print 3 times. They print it with magenta ink, then they print it with yellow ink, then they print it with cyan ink, and the 3 of those give you every single beautiful color in a book or on a box or anything where they're printing things. So let's write that down. So the primary colors of light are, as we said, red, blue, and green. The primary colors of, what am I trying to say? Pigment are yellow, cyan, and magenta. These are the primary colors of pigment. So that's how we print things. And if you've done any printing, like formal printing things, you would use those. You don't use the red, yellow, and blue because it doesn't work that way. We'll come back. If you have questions, think about them tonight and let me know. Please make sure, friends, that you do your homework over the color section so that if you have questions, we can talk about it tomorrow, okay? All right. Thanks for a fun day, you guys. Have a great day. This will be on the quiz too, but the quiz is not tomorrow. Quiz is on Monday. So we have a little bit more time to process all this stuff. Have a great day.